Before we begin, we want to warn you that this video contains images created with artificial intelligence that explore how the human body could evolve on other planets. Some of these representations may be shocking. If you are squeamish, we suggest you proceed with caution. Have you ever noticed that, depending on the science fiction movie, Martians can be short and big-headed or tall and slender? But what if I told you that those differences could have a scientific basis? Today we are going to explore how evolution on different planets could turn us into completely different versions of ourselves. As we explore how humans might evolve on planets like Mars and Venus, it's impossible not to think about what awaits us beyond our solar system. Alpha Centauri, our nearest stellar neighbor, could be the next destination in our interstellar expansion. But how would we evolve in these new worlds? If you think the human body on Earth is a marvel of evolution, wait until you see what would happen to it on Mars. Can you imagine what changes we might need to survive in space? You'll be surprised. Each planet in our solar system presents unique challenges that could change our biology. The lower gravity of Mars, the intense radiation of Venus, or the dense atmosphere of Titan, all these factors could transform our bodies in ways we cannot yet foresee. Mars could be our first stop on interstellar travel, but how would living there affect us? Would we be taller, shorter, or maybe something more unexpected? We'll find out in the next chapter. Mars, the closest planet in our quest to colonize space, presents unique challenges that would force our bodies to adapt in surprising ways. How would we change if we spent generations living on the red planet? Human skin on Mars would become thicker and darker to protect itself from solar and cosmic radiation. Without a dense atmosphere like Earth's, our skin would evolve with intense pigmentation and a tougher texture. With less sunlight than on Earth, our eyes would become significantly larger to capture more light. These eyes, disproportionate by Earth standards, would be an essential adaptation for life under the Martian sky. The thin atmosphere of Mars would cause our lungs and ribcage to expand to maximize oxygen uptake. These changes would be vital for survival in an environment where air is scarce and physical exertion is considerable. The low gravity of Mars could cause our spines to stretch, resulting in greater height. This is due to less pressure on the spine, which would allow the bones and intervertebral discs to lengthen. However, not all scientists agree with this idea. Some suggest that lower gravity could lead to shorter stature due to the lack of enough pressure to keep bones and muscles strong. This is a topic of debate in the scientific community, demonstrating how complex and fascinating human evolution on other planets is. These adaptations might seem strange, but in a world as different as Mars, they would be the key to our survival. However, not all scientists agree on exactly how we would change. Can you imagine what our evolution might be like on an even more extreme planet, like Venus? Would we be stronger, weaker, or something completely different? If Mars is a challenge, Venus is a real hell. With temperatures hot enough to melt lead, crushing atmospheric pressure and clouds of sulfuric acid, survival on Venus would require extreme adaptations. On Venus, human skin would have to be much tougher, not only to the extremely high temperatures, but also to the corrosion of acids in the atmosphere. Our skin could evolve to be as thick and tough as Kevlar and able to withstand extreme heat and constant exposure to toxic substances. Breathing on Venus would be nearly impossible without significant evolution. Our respiratory system would need to adapt to filter or neutralize toxic gases, or even to use some kind of anaerobic respiration, where oxygen is not needed. With an atmospheric pressure 92 times greater than Earth's, our bone and muscle structure would have to be extremely robust to support the additional weight. Imagine bones as dense as steel and muscles as strong as those of the most powerful animals on Earth. The thick atmosphere of Venus, laden with toxic gases and acid, would block much of the sunlight. Our eyes and other senses could adapt to perceive through this toxic haze, developing new forms of vision or even completely new senses to navigate in such a dangerous environment. Surviving on Venus would require becoming almost superhuman. But what if we could overcome even these challenges? What if one day we could adapt to a planet that is no longer so infernal, but has been terraformed to be habitable? How would we change then? Let's move on to the chapter dedicated to Titan, the moon of Saturn. Titan is a fascinating place because of its dense atmosphere and the presence of lakes of methane and ethane on its surface. Here is the chapter dedicated to how the human body could evolve on Titan. Titan, Saturn's largest moon, is a world as strange as it is fascinating. with rivers and lakes of methane, a thick nitrogen atmosphere, and temperatures hovering around -290 degrees Fahrenheit, life on Titan would require extreme adaptations. In a place as cold as Titan, human skin would need to be as insulating as that of Arctic animals. We could develop thick skin, covered in a layer of fat similar to that of seals, to retain body heat in incredibly low temperatures. Titan's atmosphere is composed primarily of nitrogen, with a small amount of methane. To survive here, our lungs would have to evolve to extract the little available oxygen or utilize a completely different metabolic process, perhaps similar to that of some microorganisms that live in extreme conditions on Earth. Titan has only 14% of Earth's gravity. In this low-gravity environment, our bodies are likely to lengthen and our bone structure to become lighter, but also more flexible, to move easily in an environment with less gravitational force. Sunlight on Titan is weak and scattered through its thick atmosphere. Our eyes could evolve to be larger and more sensitive to light, allowing us to see in an environment that is always in twilight. In addition, we could develop additional senses to navigate in perpetual darkness, such as the ability to perceive the flow of methane currents. On Titan, human life would be as alien as the environment itself. But what greater challenges await us on other worlds in the solar system? Could we find a place where our adaptations are even more extreme? If you think Titan is challenging, wait until you discover how we would change in an even more extreme world. How different could we become? Don't miss the next chapter. The most amazing thing is how our bodies could change in ways we can't even imagine. On Mars, we might see taller or shorter humans. On Venus, we might need extreme protection from radiation. And on Titan, we might see both biological and technological adaptations. These differences show us how diverse human life could be outside of Earth. Evolution on other planets is a topic full of possibilities, where science and imagination meet. While we cannot predict with certainty how we would change, we do know that each planet presents unique challenges that would shape our biology in surprising ways. This journey allows us to see how humans could adapt and evolve, showing us that life beyond Earth would be as diverse as the worlds we inhabit. We've seen how we might change on Mars, Venus, and Titan. But what if I told you that these changes could redefine what it means to be human? Don't go yet. The best is yet to come. If this evolutionary journey has left you wanting more, I invite you to explore our channel, where you will find fascinating videos on a variety of topics. From space mysteries to the latest advances in science and technology, there is something for every curious mind. If you enjoyed this journey through the exoplanets, how about we explore what life would be like in other solar systems? Leave your questions in the comments and join us on the next interstellar adventure.